So to understand this three theorems, that is Rolle's, Lagrange's and Cauchy's theorem, we need to understand the main thing, that is what do you mean by a curve, when it is said to be continuous and when it is said to be differentiable. So for that, I'll go for the whiteboard. Okay. Slowly, I'm going to the first module, first part of third module. Module 3. Module 3, we have Lagrange's theorem. Rolle's theorem, first one. First one is Rolle's theorem. Secondly, we have Lagrange's theorem. Lagrange's theorem. And third, we have Cauchy's mean value theorem. Cauchy's mean value theorem. Cauchy's mean value theorem. Okay, ma. Understand it carefully, children. These three theorems are applicable on continuous curves, continuous and differentiable curves only. When the curves are continuous and differentiable, then you can say that they hold some solution in some interval. Okay, continuous and differentiable. What do you mean by holding some a solution? Because the concept is, before going to these theorems, we need to understand literally what the continuity and the differentiability of the functions. Okay, suppose if I have x square minus 5x plus 6 is a polynomial equation equal to 0, you all know that x is equal to 3, 2 is the are the values for the function. That means that they are the roots for the function. That means this curve, that is f of x, which is equal to x square minus 5x plus 6, meets the x-axis at x is equal to 3 and x is equal to 2. X is equal to 2 and x is equal to 3. That is the meaning of the roots of the equation. So this, in meeting the point is said to be the solution of the polynomial equation. The point where it meets the x-axis is called as a solution of the equation. And this, in order to find out the solution of the curves, first we need to see whether the given curve is continuous or not. Okay, continuous. That means, what do you mean by continuity? A simple English meaning is that when you draw a curve, we should not lift our pen between the intervals where we are searching. Suppose if you are searching between 2 and 3, between 2 and 3, the curve should be a continuous curve. There should not be splits in the curve. If there is a split in the curve, it means that the curve has broken there and it is not continuous there. And suppose if I refer this curve, you can see that here and here the curve has broken here, and that what happens, we'll have the minimum and the maximum value at the same position, and you can't tell about the increasing and decreasing of the function, and you can't tell about the solution of the function. So all these are interlinked with the concept of the continuity. So whenever you refer about the theorems of mean value theorems, these are all the three mean value theorems. First thing we have to see whether the function has eligibility of these theorems or not. What do you mean by eligibility? That means it should possess some it should satisfy some condition in order to apply these theorems. So that satisfaction or two conditions are there. That is, first, that the curve should be continuous, and second, that the curve should be differentiable. So continuous means geometrically, if you understand about the continuity, it says that whatever curve you are taking, it should not be broken in the between the interval where you are searching, right? Suppose if I have x cube minus 5x square plus 7 is some curve I am referring. Taking from -2 to 2, between -2 to 2. So in between these 2 points, the curve should not be broken. Suppose if I take some point like 1 by x, some function like 1 by x, what happens? So here, suppose if I take the interval -1 to 1, you all know that at x is equal to 1, this function is nothing but that is discontinuous function because it goes to infinity. So when you plot a curve, so you can't plot the point like 0 to infinity on the graph. So what happens at that point? The curve shows the discontinuity. So that is a geometrical understanding of the continuity of the curve. And look, children, whenever you speak about this continuity, it is taken in the open interval. Open interval, what is it? Because the intervals means a specified meaning in mean value theorems. These are called as a closed intervals, and these type of curves, brackets, are called as a open curve, open intervals. So what is your difference between the closed and the open interval? Suppose if I have said a comma b is a closed interval, that means strictly I'm stopping at a and b. Suppose the same value a and b are the open interval, that means at the side, at the neighborhood of a and b, that means below a and after b, we have infinite number of points. Just like, suppose if I have open interval 0 to 1, it means that so many infinite number of points will be there around O. That is 0, that is 0.1, 0.12, 0.13, so on. So there is no end here. So the brackets are all open here. And strictly, if you say that it's closed, that means at 0, the interval has been cutted. So when you speak about the continuity, we'll speak in the open intervals rather than the closed interval. The simple meaning of the continuity is the curve should be continuous. That means when you draw it on the graph, the pen should not be lifted. Each and every point, each and every domain, the range should exist. Then you can say that that particular curve is continuous in that interval. Is clear, all of you, right? So that is the first meaning of continuity. And going to the differentiability of the curve. Let me erase this. Whenever these curves are continuous and differentiable, then you can say that they are applicable, and for applying they're eligible, they satisfies the condition of the mean value theorems, and you can apply Rolle's, Lagrange's, or Cauchy's theorem. So the next one is we have, okay. So the next one is differentiability. What do you mean by differentiability? Okay, let me take this example. Let us suppose that f of x is equal to some function we'll take where it is not differentiable. Okay, suppose root x. Okay, for all x belongs to some interval, will take open interval, or let us take from -1 to 1. Yes, -1 to 1. Let us take from -1 to 1. I am taking an example of f of x is equal to root x for all x belongs to minus 1 to 1, and just I want to understand the meaning of the word continuity and differentiability for the function. I have taken an example here, right? Now continuous, see, for all the values between minus 1 to 1, minus 1 to 1 are all real numbers. We don't have any complex numbers here, isn't it? Okay, as I'm taking open interval, I'll remove this minus 1, right? Because minus 1 is not acceptable, because if you substitute minus 1, we are going to get a complex number. So this function is not applicable on the real numbers. So for this, we'll better take the starting point as 0, so that we may not get confused. Suppose 0 comma 1, I want to refer the function, the continuity of the function in the interval 0 comma 1. So between 0 comma 1, whatever point you substitute, suppose if x is equal to 0, then f of x will be equal to 0. So if x is equal to 0, f of x will be equal to 0. F of 0 is equal to 0, right? If x is equal to 0.5, then f of 0.5 is equal to under root of 0.5, and which is nothing but some value, we'll get it 0 point some value, right? Okay, which can be plotted on the graph. So on and so forth, whatever values you take from 0 to 1, you could able to get the domain and the range here. Okay, so domain is 0.5, and suppose that the under root of 0.5 is some 0.25 some value. So here you can say that these points are domain and the range, so on up till 1 comma 1. So all these points are finite points, and they can be plotted on the curve. So we will get a continuous curve. So we don't have any doubt that this function is not continuous. Okay, so this function is always continuous. Now going to the second point, differentiability. Let us check about the differentiability of the function in this interval. Differentiability ante we have to do the derivative part. That means, what is f dash of x? F dash of x is equal to minus 1 by 2 root of x. F dash of x is equal to minus 1 by 2 root of x. Okay, you all know that when x is equal to 0, if x is equal to 0, what happens? X is equal to 0, this becomes f dash of x will become 1 by 0, which is nothing but infinity. So here the derivative does not exist at x is equal to 0. Even though the function is continuous, the derivative is not existed at that point. So this function is not applicable in this interval. I mean, in this interval it is not applicable of any one of the mean value theorems. Is it clear? Right? Okay, is it clear? Suppose if I change my interval from 0 to 1 to, I'll change my interval from 1 comma 2. Okay, see, between 1 comma 2, whatever point you substitute in the function, you are going to get a finite value, isn't it? Root of 1 is a finite value, root of 1.1 is a finite value, so on and so forth. Root of 1.99 is a finite value, and between two integers we have infinite number of rational numbers. So for all those points we are going to get a finite value. That means that for each and every point that you are substituting, we'll get a fixed point, so that we can plot it on the graph. So that means that the root 2x becomes continuous function in this interval. So from this, the idea that you have got now, the continuity of the function will be based on the interval that we are taking. మనం ఏదైతే interval we are taking, based on that interval the continuity can be discussed. So without the interval we can't discuss the continuity nature of the curves. Okay, because some curves between some points are continuous, and between another points they may be discontinuous. So like that it always happens. So whenever you discuss about these theorems, no, definitely he will give the interval. So without the interval we can't say neither the continuity or the differentiability of the curve, right? Okay, similarly in 1 comma 2, in 1 comma 2, the derivative is minus 1 by 2 root x. So if x is equal to 1 or 2, the value, the f dash of 1, f dash of 1 exists, and f dash of 2 also exists. So therefore, this curve, this curve in this interval is always differentiable, is always differentiable. But in the 0.1, it is not differentiable. In this 0.1, it is not differentiable. Just I've showed now, right? So what happens? What the conclusion is that whenever you want to check the differentiability of the function, you have to differentiate that. And in the differentiated function, you try to substitute, you try to imagine one point where it goes to infinity. Supposing if you can't get any infinite point, that means that that function is continuous in the given interval. Otherwise, it goes to a discontinuous function, or not. I'm sorry, not differentiable function. Is this concept is clear for you all? Suppose I'll take one more example. Instead of root x, I'll take one more example to discuss the continuity and discontinuity of the function. Because we, of course, we have fixed questions in this unit, but still when the question changes, you should be in the position to justify yourself correctly whether the function is continuous or discontinuous. So blindly we can't say all the functions are continuous. Blindly we can't apply all mean value theorems for it. Okay, so suppose if I have mod x, mod x for all the interval, for all interval, suppose if I take minus 1 to 1, minus 1 to 1, it is continuous, because for all the values from minus 1 to 1, mod x gives finite values, so it is all differentiable. Is it clear, right? So but if you go for the, it is continuous, it is always continuous. Is always continuous. Why it's continuous? Because but between each and every point from minus 1 to 1, the function f of x is equal to mod x is always continuous and gives a fixed values that we can plot it on the graph. The points can be capable of putting it on the graph. So it is always continuous. So going to the differentiability. What about differentiability of the function? Differentiability of such type of functions, mod functions, have to be checked for LHD and RHD. That means left hand derivative should be equal to right hand derivative. So whenever you get mod functions, in order to check the differentiability, we have to check whether the left hand derivative is equal to right hand derivative. What do you mean by left hand derivative? Left hand derivative, suppose if I want to check it around x is equal to 1, I want the differentiability of the function of around x is equal to 1. Just we have to check whether the limit x tends to 1 minus f of x is equal to limit x tends to 1 plus f of x or not. So these two things we need to check it now. Here you see 1 minus. You all know that the mod function takes two different types of values. Minus x if x lies in the domain less than 1, right? And plus x if x is taken greater than 1. Of course, it becomes 0 when x is equal to 0. So if it is x, so two types of values it accepts. So here what happens? The limit of x tends to 1 minus f of x becomes minus x, and here limit x tends to 1 plus, that means after plus the mod function will acts like plus 1. So 1 plus it acts like x. So when you substitute x is equal to 1 here, 1 minus, it doesn't mean that minus 1 minus means that the value is below minus 1. So atla ardham vastadi. Is it clear, right? 1 paina minus pettina ఐ మీన్ సరే ఏ మైనస్ కి మైనస్ ఏ కి చాలా తేడా ఉంటుంది. ఏ మైనస్ అంటే వీఆర్ రెఫరింగ్ టు ద నంబర్స్ విచ్ బిలో మైనస్ ఏ, అండ్ మైనస్ ఏ అంటే వీఆర్ రెఫరింగ్ ద ఐ మీన్ minus of a like this. So that there is a lot of difference here. సో ఇక్కడ మనకి ఏమవుతుంటే x is equal to 1 సబ్స్టిట్యూట్ చేస్తే -1 వస్తుంది, అండ్ ఇక్కడ 1 సబ్స్టిట్యూట్ చేస్తే 1 వస్తుంది. సో -1 is not equal to 1. Therefore this function is not differentiable. Mod functions are not differentiable functions. ఎప్పుడు కూడా mod functions కి మనము డిఫరెన్షియబిలిటీ అవ్వవు. ఎప్పుడు అవ్వవు అంటే మనం తీసుకున్న ఈ ఇంటర్వెల్ ని బట్టి. ఇంటర్వెల్ మనం ఏం తీసుకుంటున్నాం ఇక్కడ చూడండి అమ్మా, 0 నుంచి సేమ్ -1 + 1. ఎప్పుడైతే మన ఇంటర్వెల్ -a to a ఇలా తీసుకుంటామో మోడ్ ఫంక్షన్స్ కి ఎప్పుడు డిఫరెన్షియబిలిటీ ఇవ్వదు. అలా కాకుండా సపోజ్ ఇఫ్ యూ టేక్ ఫ్రమ్ a to b, both are positive or both are negative, అప్పుడు అది డిఫరెన్షియబిలిటీ ఇస్తుంది. సో I want to say that the differentiability and the continuity are completely depends upon the interval that we are taking. Man తీసుకుంటున్న interval ని బట్టి differentiability and continuity will be dependent, but not blindly. As you like, we can't say without the interval, we can't say whether it is continuous or differentiable. So ఇవి రెండు మనకి చాలా మెయిన్ పార్ట్స్ గా, I mean main characters లాగా ఉంటాయమ్మా whenever you want to apply these three theorems. So till now I didn't go for the theorems ఇంకా ఓపెన్ చేయలేదు. Just I have discussed about the continuity and the differentiability of the function. Tell me if you have any doubts in this. Please tell me if you have any doubts in this. Please put it in chat box. మనం డౌట్స్ ఉంటే చాట్ బాక్స్ లో పెట్టండి. అరే వింటున్నారా? నేను ఒకదాన్ని చెప్పుకుంటున్నానా? Are you all listening? ఓకే, వింటున్నాం మ్యామ్. వింటున్నారో అక్కడ తినుకుంటా వింటున్నారు ఏమోరా. This is too bad. All the 3 units are very tough. Hope so that we'll have offline classes soon, because the coming 3 units are very difficult. They are not just like matrices. Already I've alerted you people, but our bad luck that when I started my typical topic, we have online classes. I felt very bad yesterday. Okay, so February lo manaku offline classes untayani aashiddam. Got my point? Right. Okay, please take down the continuity of the function. Continuity of the function. Situation demands. Right. Right. Amma, somebody have asked some interval. Continuity also depends on interval. Yes, continuity and differentiability and adi manaki interval ni batte untayi amma. Okay, interval ni batte untayi. Is it clear? Endukante ippudu suppose nenu I'll take an example like x to the power of 3/2 annanu ankura. If I take some example, a function just like this, idi continuous ah kaada ante em cheptavu daniki? Em cheppalem. Is it clear? Ade suppose I want to check the continuity ante a curve continuous ah kaada ani naku interval lo ee interval lo check cheyalanunkunnanu anko, appudu nu cheppagalugutu adi nijanga ee interval lo 1, 2 madhyalo aa curve eppudiki continuous untundi. Endukante nu ఏ వాల్యూ ను తీసుకున్నా x ప్లేస్ లో in between this 1 and 2 నాకు infinite values గాని indeterminate values గాని ఇవ్వదు. So suppose if it is giving any infinite or indeterminate values, you can't see. This is the range domain that you are taking. 1 అని తీసుకుంటున్నాం. The answer is if you substitute 1, some value will get it, right? That is the domain value. So two coordinate pairs x comma y ఉంటాయి. So if x and y both are finite, then you can flexibly put it on the graph. Suppose if x is finite and y is infinite, what happens? You can't put the point on the graph, isn't it? Suppose I want you to ask where does this point lies, 1 to 2 to infinity, where you are going to put that point? పెట్టలేం కదా. సో అట్లా ఏమవుతుందంటే అది డిస్కంటిన్యూస్ అవుతుంది. అర్థమైందా? ఇప్పుడు నాకు పాయింట్ ఇది వచ్చిందనుకోరా, 2, ∞ అని వచ్చిందనుకో, ఏదైనా ఒక పాయింట్ 2, of course you can plot it x value 2, but y value infinity అన్నప్పుడు నువ్వు ఎక్కడ పెడతావు ఆ పాయింట్ వెళ్ళినప్పుడు కర్వ్ అక్కడ వరకు వచ్చి ఏమవుతుందంటే డిస్కంటిన్యూస్ అయిపోయి మళ్ళీ వెళ్ళిపోతుంది అది. ఈ పాయింట్ దగ్గర మనకి ఎంత 2, ఇన్ఫినిటీ ఉంది కాబట్టి ఇట్ ఈస్ డిస్కంటిన్యూస్, ఇట్ బ్రేక్స్ ద కర్వ్ ఈస్ డైరెక్ట్లీ బ్రోకెన్ అని చెప్పొచ్చు అనమాట. గాట్ ఇట్? ఓకే. సో డస్ ద continuity also depends on the interval? It always depends upon the interval, not situation. It always depends upon the interval. Any doubts? Any doubts, ma? And tell me one thing, Nana. When the tan theta, suppose if I have tan theta, right? Tell me this function f of theta, where at what point of theta the function is continuous, discontinuous. Tan theta ni chandra. So ఇది డిస్కంటిన్యూస్ కర్వ్ అందరికీ తెలిసిన విషయం. దట్స్ గుడ్. 90 degrees దగ్గర, ఎందుకంటే మనకి tan 90 degrees దగ్గర ఏమొస్తుంది, tan 90 degrees దగ్గర ఇట్ గోస్ టు ఇన్ఫినిటీ అయిపోతుంది. ఇస్ ఇట్ క్లియర్? ఇన్ఫినిటీ అయిపోతుంది. సో యూ కాంట్ పుట్ ఇట్ ఆన్ ద గ్రాఫ్ లో, మనకి 90 degrees దగ్గరకు వచ్చి అది ఆగిపోతుంది అది కర్వ్. అందుకే ఎక్కువ చూడండి మనకి మోస్ట్ ఆఫ్ ద tan కర్వ్స్ విల్ బి ఇన్ దిస్ మోడల్, ఇలా డిస్కంటిన్యూస్ కర్వ్స్ వస్తూ ఉంటాయి. అదే మీకు సైన్ కర్వ్స్ అనుకోండి, దెల్ బి లైక్ దిస్, ఇజంట్ ఇట్? ఇట్లా ఉంటాయి సైన్ కానీ కాస్ కానీ, ఇట్లా కంటిన్యూస్ కర్వ్స్ వస్తాయి మనకి. గాట్ ఇట్? ఇప్పుడు దిస్ మీన్ వాల్యూ థియరమ్స్, యు నో, దే ఆర్ ఆల్వేస్ టెల్స్ వేర్ the, I mean, at what interval, from what interval to what interval the functions are continuous, and at what point that touches the x-axis. Does it touches the x-axis? కొన్ని curves, some curves, no, before touching the x-axis they'll go like this. So the point where it touches the x-axis, that we are taking as a solution. If it doesn't touch us, that means that the solution at that interval, ఆ interval లో అసలు ఆ curve కి అసలు సొల్యూషనే లేదు. అర్థమవుతుందా? సపోజ్ ఇఫ్ ఐ లాస్ట్ మై రింగ్ ఇన్ దిస్ రూమ్, ఇట్స్ వేస్ట్ ఆఫ్ సర్చింగ్ మై రింగ్ ఇన్ అదర్ రూమ్ వేర్ ఇట్ వీ హ్యావ్ లైట్, ఇజంట్ ఇట్? సో నేను ఎక్కడ పడుచుకున్నాను అక్కడే ఎత్తుక్కోవాలి. అట్లనే ఇప్పుడు నాకు ఇంటర్వెల్ ఇక్కడ 2,3లో నాకు ఆన్సర్ రావాలి అంటే ఇక్కడ రావట్లేదు ఇది, ఎందుకంటే ఆ కర్వ్ దిస్ ఇంటర్వెల్ లో అక్కడ ఎక్కడ టచ్ అవ్వట్లేదు, బికాస్ ఇట్ డజంట్ హ్యావ్ ఎనీ in a point of intersection of the curve with the x-axis. So manaki solution undadu. So ivanni ultimately so interval solutions untaya leda, so whether we are able to get the solution or not, or sometimes no, how the curve is moving, ante adi increase avutunda, whether it is decreasing or it is going to the peak points, or the having the minimum points, all this, that is knowing about the characteristics of the curves. We are going to learn first the mean value theorems. Mean value theorems nunchi emavutundante, we can tell whether the functions are increasing or decreasing, whether they are discontinuous or not continuous అని చెప్పొచ్చు. So if it is continuous అయితే మనకి at what point, up till what point the curve is going, a peak వరకు point curve వెళ్తుంది, what is the maximum value? Okay, all that we can discuss, which is the second part of the third unit. For this purpose, this mean value theorems are discussed, children. Look children, see the functions will be varying amma. Functions manaki edi padate adi istuntadu, interval kuda marusta untadu, right? Okay, so we can't we can't tell as we like, right? Okay, so first we need to understand the concept properly. We have to understand the concept properly, because we need to apply the concept to random questions and in random intervals. Okay, all questions are not alike. We don't get any fixed problems here. Okay, the student should understand the concept of continuity and differentiability, and he should be well prepared to give answers whether the RMBT, that is Role mean values theorem, is applicable kada, or Cauchy's mean value theorem is applicable kada, or what you have, that is Lagrange's mean value theorem is applicable kada. If it is applicable, where the point, the C value, at what point the curve meets the x-axis, at what points the curve meets the x-axis. So all that we need to understand. Okay, so ఏమైనా డౌట్స్ ఉంటే చెప్పండి. అటెండెన్స్ ఈస్ టేకెన్ ఇన్ ద జూమ్ ఇట్ సెల్ఫ్. జూమ్ అంటే రికార్డ్ తీసుకుంటే వచ్చేస్తుంది. సో డోంట్ వరీ అబౌట్ యువర్ అటెండెన్స్. అటెండెన్స్ ఇది ఆటోమేటిక్ జనరేట్ అయిపోతుందమ్మా దీంట్లో. ఇంకా ఎనీ డౌట్స్? excellent work. No doubts. మీకు ఇప్పుడు ఏం నో నో యూ డోంట్ హ్యావ్ ఎనీ డౌట్స్ అమ్మా, ఇప్పుడు ఏం రావు. అది మనం అప్లై చేసేటప్పుడు కంపల్సరీ వస్తాయి. సో యూ టెల్ మీ వెన్ మీకు ఇప్పుడు అర్థమైనంత వరకు వాట్ అప్ టిల్ నౌ. ఓకే, వెన్ ఎ ఫంక్షన్ ఇస్ సెట్ టు బి, it is compulsory to attend on the, yes, it is compulsory to attend the online classes amma, because here when you log in, no, the time, the duration that you are there here, automatically it is generated, guys. సో మీరు నేను ఇప్పుడు ఎక్సెల్ షీట్లో అటెండెన్స్ తీస్తే మీకు వచ్చే మీరు ఎంత ఏ టైంలో లాగిన్ అయ్యారు, ఏ టైంలో లాగౌట్ అయ్యారు, ఎంత టైం వరకు ఉన్నారని కూడా తెలుస్తుంది. సో 1 minute 2 minutes 5 minutes అట్లా ఉంటే అది అటెండెన్స్ తీసేస్తారన్న. ఓకే, కంప్లీట్ గా ఉండాలి. ఇది క్లాసెస్ మీకోసం, మా కోసం కాదురా అమ్మా. దిస్ క్లాసెస్ ఆర్ టేకెన్ ఫర్ యువర్ సేక్. మా సబ్జెక్ట్ చెప్పుకోవడం కాదు ఇక్కడ మీకు అసలు, because we won't get again and again this. There is no repetition of this subject which we are taking in online. So please be attentive. అందుకే నేను ఎన్ని ఎగ్జాంపుల్స్ తీసుకుంది కూడా, సో మెనీ ఎగ్జాంపుల్స్ హ్యావ్ టేకెన్ టు మేక్ యూ అండర్స్టాండ్, బికాస్ టిల్ నౌ యూఆర్ హ్యాంగింగ్ ఆన్ మ్యాట్రిసెస్ విచ్ ఈస్ అ వెరీ సింపుల్ టాపిక్. ఓకే, దానికి దీనికి పొంతన లేదు. ఫస్ట్ 2 topics అండ్ థర్డ్ టాపిక్స్ హాస్ నో ఇంటర్లింక్డ్. ఐ టోల్డ్ ఇట్ ఆల్రెడీ. ఇది బాగా కాన్సెప్ట్ డెప్త్ ఉండే టాపిక్స్ ఇవన్నీ. దట్ ఈస్ ద ఫంక్షన్స్ ఆఫ్ సెవరల్ వేరియబుల్స్, మీన్ వాల్యూ థియరమ్స్. Of course, problems are very easy, guys. Problems are very easy, but before writing any statement, we have to think once or twice. ఎట్లా పడితే అట్లా రాయడానికి వీల్లేదు. కొద్దిగా మనకు మీనింగ్ తెలుసుంటే అప్పుడు దాని గురించి we can write it very easily, right? Okay. ఏమైనా డౌట్స్ ఉన్నాయా? Tomorrow I am going to give the definition slowly. Definition of continuity, differentiability with examples. ఇచ్చి మెల్లిగా స్లోగా స్టార్ట్ చేస్తాం, because we have much time. ఫర్ ఫస్ట్ మిడ్ ఇంకా టైం ఉంది కాబట్టి. ఇంకా ఈ లోపు ఏమైనా డౌట్స్ ఉంటే మీరు చెప్పండి అమ్మా. I asked the man to unmute it, because ఈ మ్యాథమెటిక్స్ లో షేరింగ్ ఉంటేనే I could able everything. I can't put it in the you can't write it in the chat box కదా. సో మేడం నా రిక్వెస్ట్ చేస్తాను, రైట్? ఓకే. See, so this is such a lengthy topics we have. Once again, I'm showing you the topics in these 3. This is on the first 2 on single functions, and this is on double function. Cauchy's theorem is on double functions, right? Okay, all the
Anyone respond? Hello.
Hello.
Am I audible now?
Yes, sir.
Okay, right. Okay. Ma'am. So we are discussing the maximum power transfer theorem. So in the morning class, we have done this. We also solved one problem. So still a few more problems we are going to solve in this class. So what is maximum power transfer theorem? According to the maximum power transfer theorem, maximum power will be delivered from source to load whenever load resistance will be equal to source resistance. Okay, right. So if you have a network like this, one voltage source which is having a source resistance RS, and this is the voltage source Vs, and here you have the load resistance. This load resistance is a variable resistance. Now, while changing this RL, if the RL becomes equal to the source resistance RS, so then you can say that maximum power will be delivered to the load. Okay, so if you represent that in a graphical mode, so take the load resistance on x-axis and power delivered to the load on y-axis, and you draw the graph by increasing the load resistance RL. Right, we are changing the load resistance from 0 to some value. Now, whenever this load resistance so will become equal to the source resistance, in such a case, you can observe the maximum power. Okay, so maximum power will be delivered to the load whenever this load resistance will become equal to the source resistance. Now, if you still even increase beyond this the load resistance, the power delivered to the load will be decreasing here. Okay, so from 0 to RL, which is equal to RS, so your power delivered to the load is going on increasing and reaching the maximum value. Then at RL is equal to RS, the maximum value will be there. So beyond that, again it will decrease. So this is the maximum power transfer theorem graph. Right. So now if you calculate the maximum power, right, at this condition, so when RL is equal to RTH, as according to the maximum power transfer theorem, power will be delivered to the load will be maximum. Now, what is the amount of power that will be calculated using this formula? So P max is equal to V Thevenin square by 4 into R Thevenin. So here, what we need to do is, so if you are given any circuit, so suppose I'm taking one arbitrary circuit, it may be having number of voltage sources and number of current sources and number of resistances will be there. Okay, so like that, you may be having many number of sources also, and many number of resistances also will be there. Okay, now here at the last, you will be having a load resistance, okay, which is represented with RL. Okay, so now for simple case, we know how to simple case is nothing but one voltage source in series with one resistance and one load. So for this, you can usually apply the Thevenin's this maximum power transfer theorem, such that RL will be equal to RS. Okay, so but if a complicated circuit like this it is given, then what you need to do, first of all, between the terminals A and B, or between the terminals which is low terminals, you need to find out the equivalent Thevenin circuit. Okay, Thevenin's equivalent circuit you need to find out. So then that total circuit will become like V Thevenin's in series with the R Thevenin's. Okay, so now the total entire circuit, so between the terminals A and B, so will be replaced by only one single voltage source in series with the resistance, and the voltage source value is V Thevenin, resistance is the R Thevenin. Now, so between the AB terminals, again you will connect the load resistance RL. Okay, now the source resistance is going to become this R Thevenin, and source voltage will be V Thevenin here. Okay, so from this circuit, you can easily say that whenever RL will be equal to RTH, then the maximum power will be delivered to the load, and the amount of maximum power will be equal to this Pmax is equal to V Thevenin square by 4 RTH, and the derivation for this maximum power we already derived in the morning class. Okay, so you have to remember these two ones. So condition for maximum power transfer is RL is equal to RTH, and the amount of maximum power will be VTH square by 4 RTH. Okay, let us see one more problem. So in morning class we have done one problem. So let us see the another problem. So determine the value of resistance. Determine the value of resistance R. This resistance you need to find out, such that maximum power transfer takes place in the circuit. Okay, and also find the maximum power delivered. Okay, so here they may even extend this. Okay, also find the value of maximum power. Okay, so now here in this circuit you need to determine the resistance R, so where the maximum power will be taking place, right? So now between these two terminals, here you are checking X and Y terminals as the terminals of your R, or you can even take this as simply load resistance RL also. Okay, so you assume that this R will be your load resistance. Okay, now the terminals of this load will be, here we are calling them as a X and Y. Now between X and Y terminals you have this total circuit. Okay, so now this total circuit, by using Thevenin's theorem, you have to replace with the Thevenin's equivalent circuit, in which one voltage source will be in series with one resistance, right? And the value of voltage source will be V Thevenin, and the value of resistance will be R Thevenin. Now between the terminals X and Y, again finally you will replace this load resistance RL. Now to the maximum power. So now for in this circuit, the maximum power will be delivered to the load whenever the value of RL will be equal to R Thevenin. Now here RL is nothing but simply your R in the circuit. Okay, so this is R is equal to R Thevenin. Then maximum power will be delivered to the circuit. Okay, so you need to determine the R Thevenin. Okay, so that R Thevenin will be equal to R. So in such a case, maximum power will be delivered. Right? How you can determine the R Thevenin? Already you know. So while determining the R Thevenin, you need to short circuit the voltage sources and open circuit the current sources. Right? Here you have the one voltage source. Right? So that voltage source will be short circuited. Okay. So then here you have one resistance, which is 4 ohms. So then you have 2 ohm resistance here. So then here you have 6 ohm resistance. Now here you have the voltage source. So this voltage source again, it will be short circuited. So you will be having direct connection to the ground. Okay. Now here you have the terminals X and Y. Okay. So now here, if you find the equivalent resistance, so that will be equal to the R Thevenin's value. Okay. See here, let us assume that your current is coming like this. So here at this point, your current will be going like this. Now this current at this point, if you observe here and here, the current has to flow. So but if you observe this side, you have the total entire short circuit. The resistance will be 0 here for short circuit. So in such a case, the total current coming from 2 ohms will be going through this short circuit only. So no current will flow through this 4 ohms. So in such a case, you need not to consider this 4 ohms here. Okay. So your circuit will be simply this 2 ohms and this 6 ohms. So like this will be there. So now the equivalent resistance between these XY terminals will be your R Thevenin. So the R Thevenin will be equal to, so now between these 2 points, these two are in parallel. So 2 is in parallel with the 6. So 2 into 6 by 2 plus 6 you will get. So 12 by 8. So this is your Thevenin's R Thevenin's value. Okay. So according to this problem, so determine the value of resistance R such that maximum power transfer takes place in the circuit. Okay. They asked to find out the value of resistance R. Okay. So that R will be equal to R Thevenin's only. Now here we were R Thevenin's value. So simply the R value will be equal to R Thevenin. In such a case, the maximum power will be taking place. Okay. So up to this, you can conclude. Okay. So no need to derive V Thevenin's. Again, no need to derive P max for this problem. Okay. They were not asked here, right? So suppose if they were asked to find out the value of maximum power, then you have to find out the V Thevenin. Then you have to find out the P max by using the formula V Thevenin square by 4 RTH. Okay. So if they are asking only the resistance at which maximum power transfer take place, in such a case, you just need to find out only RTH. That RTH will be the value of resistance. So where the maximum power transfer will take place. Okay. Right. Suppose, so for the same problem, so here they are extending this problem such that find the value of P max also. Okay. So now, so to determine the P max value, what is the formula? So P max is equal to V Thevenin square by 4 RTH. Okay. So now RTH you already find. So now for determining this P max value, you need to calculate both VTH as well as RTH, right? So between the terminals X and Y, and by considering this entire circuit, you have to replace this circuit with one voltage source VTH in series with the resistance RTH, and these two VTH and RTH both you need to find out. Then finally you have to connect the RL here, this R. Okay. So then you can find the current flowing through this, and power P max will be equal to I square into R plus RL. Okay. So the condition for maximum power will be RL is equal to RTH. Okay. So now the P max. So actually this is the load power. Okay. Load power PL is equal to I square into RL plus RTH you will get. Now if you apply this condition, so then the power will become maximum power. So which will be equal to I square into R Thevenin plus R Thevenin. So like this you can write. Okay. Or you can directly use this formula also. Okay. Let's see here. So how you can find out the V Thevenin. So the Thevenin's voltage for this circuit here between the terminals X and Y, you need to find out the V Thevenin. Okay, V Thevenin will be the open circuit voltage, you can say. Okay, across the terminals X and Y where the load is connected. Okay, initially first you have to remove the load, and after removing the load you will get two terminals. Those two terminals you can call it as either A and B or X and Y. Now between those two terminals you need to find out the open circuit voltage. That value will become the V Thevenin. Okay, so now for finding this V Thevenin, you can apply any circuit techniques, right? So you can use the KCL, or you can use the KVL, or any other network regression techniques also you can use. Okay, so here they are using KVL. Okay, so now here if you see there are two loops are there. Okay, so you assume the loop currents. Here they are assuming the loop currents are flowing in the clockwise direction, and the currents are represented as I1 and I2. Now for each loop you have to apply the KVL, and you have to write the one mesh equation. Okay, so mesh equation for, if you write for first loop, so 12 minus 4 into, so this the current flowing to this 4 ohm is I1 minus I2. I1 is coming from top to bottom, I2 is from bottom to top. So I1 minus I2 will be the current flowing to this 4 ohm resistance. Okay, so that current value into that resistance value 4 ohm will be the voltage across the this. Okay, in a loop according to KVL, all voltages will be equal to 0. So this is minus plus. Now here this is plus minus. Okay, so while if you assume this for resistance, this is plus and minus, and for this is plus and minus, and for this is plus minus. Okay, so now you have to find out the voltage across all the elements, and you have to take the sum, and it will be equated to 0. Okay, I think you already know how to apply this KVL in a particular loop. So if you take a second loop, so minus 2 I2. So here you have the 2 ohms. Voltage across this will be this loop current I2 into 2 ohms, right? So it is the current flowing through plus 2 minus. Sorry.
बंद करो, नेट में बात करो शाम में. Yes, sir. I meant, అవును సార్, అవును సార్.
Here, Amma, don't switch on your mic in the middle. Okay. So you apply the KVL here in the second loop. So then in source, the current is flowing from. So according to this direction of current, you have to assign the positive and negative polarity here. Okay. So now if you observe, this current is flowing from positive to negative, positive to negative, positive to negative, positive to negative. In all the elements, it is flowing in the flowing from positive to negative only. So the sign will be negative for all the elements. Okay. So voltage across 2 ohms will be minus I2 into 2 ohms. And voltage across this 6 ohms will be minus 6 into I2. And then for voltage source also, it is going from plus to minus only. So you will get minus 10. And if you see the 4 ohms, then current flowing to this is I2 minus I1. So 4 into I2 minus I1 is equal to 0. Okay. So now you solve this, you are getting this equation. Okay, for mesh 1, so this is the equation. Okay, now if you solve this equation 1 and equation 2, you will get the currents. Loop currents you will get. Loop currents I1 you are getting here is 3.25 amperes and I2 is 0.25 amperes. Okay. So now after getting the currents, our main aim here is that you need to find out the voltage across this X and Y. So which is the Thevenin. Now voltage across this Thevenin is nothing but it is the voltage across this point and this. Okay. So between this. So this point and this point, you can say voltage across these 2 points is same as the this Thevenin. Okay. So see here. Now between these 2 points, your voltage is Thevenin. Let it call this is plus terminal and minus terminal. And here you apply KVL. Okay. So here minus to plus, this will be plus to minus. So then 10 minus. So minus to plus, plus to minus like that, right? So 10 volts. So here plus 2 minus it is there, right? Plus to minus you can say minus 6 I2 plus to minus again minus VTH is equal to 0. Actually this you have to write. Okay. So then VTH will be equal to, so 10 minus 6 I2. Okay. So the current, depending upon the direction of current, actually you have to write this. Okay. So what is the direction of current? Okay, if you observe the previous one, right, this loop current I2 is flowing from top to bottom. So this is the direction of current. Okay, that means anti-clockwise direction it is. Okay, so when it is the direction of current flowing through this, which is I2, right? You can assume the direction in this way. Okay, so this is plus and minus only. So now according to direction of current, this will become positive and this will become negative. This will be positive and this will be negative. Now minus to plus, you can consider it as a positive Thevenin. Then plus to minus, you can consider it as a negative 6 I2. Then voltage source will be plus to minus again. So this is minus, plus to minus, minus 10 is equal to 0. Right? Thevenin is here also the same. So 10 plus 6 I2. Okay. So now I2 value already you know. I2 value is 0.25. Okay. So 10 plus 6 into 0.25. Okay. So how much you will get? So 0.25. What is this value? So once calculate. So 10 plus 6 into 0.25, you will get 11.25, 11.5 volts. Okay. So here they were represented this wrongly. Okay. So actually this is correct. Okay, Thevenin minus 6 I2 minus 10 is equal to 0. So then Thevenin is equal to 10 plus 6 I2 will get. Now the I2 value is 0.25. So finally you are getting 11.5 volts. Right? Here they represented wrong. So 10 minus this value, it would be less than 10 actually. Why they are putting 11.5? So this is wrong. So you follow this. Okay. So VThevenin you are getting 11.5 volts. Okay. So then what is the RThevenin's value? RThevenin's value we already calculated. Okay, as it is a short circuit, so this will not have any preference. Okay, so 2 ohms in parallel with 6 ohms will be the RThevenin's value. So that will be 1.5 ohms. We already calculated before itself. Okay, so now we got the VThevenin's and we got the RThevenin. So now you have to represent the equivalent Thevenin circuit, so which is a VThevenin's value in series with the RThevenin's value. VThevenin's here is 11.5, RThevenin is 1.5 ohm. Now after this, you have to connect the load resistance RL value here. Okay, so now, so when the maximum power will be delivered, according to the maximum power transfer theorem, the maximum power will be transferred to the load whenever this load resistance will become equal to Thevenin's resistance. Okay, so now RL is equal to RTH. In such a case only maximum power will be transferred. So RThevenin we already determined the value is 1.5 ohms. So RL also the same 1.5 ohms. Okay, here RL also the same value. Okay, now power delivered to the load. So power delivered to the load will be equal to, under maximum power transfer condition, this value will be the P max. The P max value is equal to VThevenin square by 4RL. Now this RL value is 1.5 ohms and VThevenin's value is 11.5 ohms. You just simply substitute them. You are getting 22.04 watts as the maximum power delivered to the load. Okay. Right. See another problem here. So determine the value of load resistance that receives the maximum power from the supply and the maximum power under the maximum transfer condition. Here they ask to find out the load resistance at which maximum power transferred, right? So this will be equal to RThevenin. Okay. So and also they ask to find out the P max value, so maximum power under the maximum power transfer condition they ask. Okay, so P max will be equal to VThevenin by 4 into RThevenin. So VThevenin square this one. Okay, so again the same procedure you have to follow, and the load resistance here is this one. Okay, so first you remove this load resistance and you call the terminals as A and B or X and B. So that is your wish. Okay, so between the terminals A and B here, you need to find out RThevenin as well as VThevenin. Okay, and finally you have to replace this circuit with the VThevenin in series with the RThevenin. Okay. Now between these two terminals A and B, finally we will connect the load resistance RL. Okay, so then you can find the maximum power transfer from this expression. So first, how you can determine the Thevenin's voltage or voltage across the terminals A and B. Okay, so voltage across this terminals A and B will be the VThevenin. Okay, so now how you can determine here the voltage across A and B? Suppose voltage across this A is VA and voltage across B is VB. So then VThevenin will be difference of these two. Okay, VA minus VB. Okay, so VA minus V voltage across A and B will be equal to voltage across A minus voltage across B. Okay, so now you need to find out the what is VA and what is VB. Now, if you see here, this is entirely one element which is connected across the voltage source 30. So that means you have the 30 volt source here. Now between the between these 30 volts terminals, you have two resistances which are connected in series. Okay, now here you need to find out the voltage. That means with respect to the voltage across this will be VA. Okay. Similarly, you have another two resistances which are connected in parallel and need to find out the voltage across this point. Voltage across this point is nothing but voltage across this point and ground you have to represent as VB. Now voltage across these two terminals will be VAB, which is equal to VA minus VB. Okay. Right. So first find out the what is VA and what is VB. Okay. Now, when two resistances are connected in series and you need to find out the voltage across any element, you can use the voltage division rule. Okay. You can apply the voltage division rule here. Simply determine VA and VB. Now, so this is the series circuit, so which is connected across your source 30 volt. Now, voltage across this second resistance, 20 ohms resistance will be VA. So that VA is equal to source resistance, source voltage 30 volts multiplied by this resistance value 20 by 20 plus 50. So this is according to the voltage division rule. Similarly, these two series resistances are connected across the same 30 volts. So the value of VB will be equal to 30 into, so this resistance, what is this value? 5 ohms. So 5 by this sum of these two, 5 plus 10. Okay. So VA is 30 into 20 by 20 plus 15. VB is 30 into 5 by 5 plus 10. Okay. If you solve this, VA you are getting 17.14 volts. VB you are getting 10 volts. Okay. So once you get the VA and VB, so VThevenin will be equal to VA minus VB. Okay. So VA voltage across AB terminals will be the same as VThevenin, and this VThevenin value will be equal to VA minus VB. So the VA value is 17.4 and VB value is 10. So VAB will be 7.14. So which is same as the VThevenin value. Okay, you got the VThevenin as 7.14 volts. Okay. Here instead of using KCL and KVL, I used this voltage division rule. Okay, you can use even the KVL or KCL also. You will get the same value. Okay. So next, after determining the VThevenin, you need to find out the RThevenin. Okay. So while finding the RThevenin value, if there are any voltage sources in the circuit, then those has to be replaced by short circuit. If there are any current sources, those has to be replaced with open circuit. Okay. So here in the problem, you have one voltage source here. So this voltage source will be replaced with a short circuit here. Okay. So here you are not having any voltage source. That voltage source is replaced by one short circuit here. Okay. So now you need to find out the equivalent resistance between the terminals A and B. So which will be the RThevenin value. Okay. So now if you see here, the resistance R1 and this resistance R2. So these two are connected between the same nodes. Okay. So now this node will be same as this node only. Why? Because we are connected these two with one line. Okay. So these two are same. So if you take A here, so then this R1 and R2 are connected between the same nodes. Okay. Yeah, this node, if you take this as the ground node, let us say, or 0 node, then this will be the one. Okay. Now, in similar way, this R3 and R4 also connected in parallel. Okay. So those are also connected between this point B and other point will be this 0 only. So here this R3 is connected in parallel with the R4. And here you are having the terminal B. Now, this total resistance across this A and B will be your RTH. Okay. So the RTH will be parallel combination of these two and plus parallel combination of these two. Okay. So RTH, which is the resistance across RAB, will be equal to R1 in parallel with the R2 plus R3 in parallel with the R4. Right? R1 in parallel with R2 is nothing but R1 R2 by R1 plus R2. R3 in parallel with R4 is nothing but R3 R4 by R3 plus R4. And the value of resistances are given here. R1 is 15 ohms, R2 is 20 ohms, R3 is 10 ohms, R4 is 5 ohms. So you simply substitute all the values here in this equation. So then you will get the RThevenin value. Now RThevenin value here we are getting it to be equal to 11.9 ohms. Okay. So you got the VThevenin, you got the RThevenin. Now you draw the Thevenin's equivalent circuit. So in Thevenin's equivalent circuit, simply you have one voltage source in series with the Thevenin's resistance. Okay, Thevenin's voltage is 7.14 you are getting, and RTH is the 11.9 ohms. Now between the terminals A and B, you are connected the removed load resistance RL. Okay. Now the maximum power will be delivered to the load. So whenever this RL value will become equal to RTH, that means RL will be equal to 11.9 ohms. So in such a case, maximum power will be delivered, and the amount of maximum power will be equal to P max, which is the Thevenin square by 4 RTH, and the Thevenin's value 7.14 whole square by 4 into Thevenin's value is 11.9. Okay, if you solve this, the maximum power delivered to the load under maximum power transfer condition will be equal to 1.07 watts. So this is how you can determine the maximum power delivered to the load. So by using maximum power transfer theorem as well as Thevenin's theorem. Okay. So without Thevenin's theorem, you cannot determine here. Okay. Right. See the another problem here. So this is the question bank problem. Okay. Instead of giving the circuit, they've given some description here, and you need to find out the resistance at which maximum power transfer will be there. Okay. See here, in a series circuit, a source resistance of 45 ohms and a load resistor of RL with a 20 volts DC supply. You have a series circuit. Okay. You have a series circuit in which 20 volts DC supply will be connected with some source resistance RS, in which this value is 45 ohms, and load resistance RL. So this is the circuit given here. Okay, RS value is 45 ohms, and source value is also given. Okay, so this you can even call it as this is Thevenin, and this is Thevenin, and this is load. Okay, now here this load resistance value is a variable resistance, and the variable resistances are given here directly. So these values are 10, 20, 30, 40, 45, 50, 60, and 70 ohms respectively. They are given. Okay. Now you need to calculate for what resistance. For what resistance of the load maximum power will be transferred. Okay. So here they were given some values of resistances. A list of values of resistances are given. At what value of these resistances maximum power will be delivered to the load? They asked this. Okay. So they also asked the maximum power value, current and voltage drops in each case. Okay. So you need to find out here what is the resistance RL at which maximum power will be there, and you also need to determine the maximum power value, PM value, and you also need to find out the current I, and also need to determine the voltage drop across RL, IL, this in each case. Okay. So simply this problem is similar to the problem which you already done in your laboratory only. Okay. A list of resistances are given in the lab, and you ask to find out the maximum power delivered to the load at what value of resistance maximum power will be delivered. Okay. So there you have done the theoretical values. The same procedure also you need to follow here on. Okay. So here you make a table RL. Okay. RL values are listed here 10, 20, 30, 40, like that. Okay. You do this. Okay. So then, so you find the load current. Okay. So this load current will be equal to how much? So source voltage Vs by source resistance plus load resistance. So by using this formula, you have to find out the load current IL. So load current is nothing but current coming from the source. Current coming from the source IS and current flowing through the load IL, both are same. Okay. So the IS will be equal to IL, which will be equal to 20 by series combination of these two resistances. Okay. And this is RS value is always 45 ohms. And the RL value it is changing here. For each value of RL, what is the IL you find out. So then, so what is the value of VL? So once you know the IL, the VL you can find it easily. Okay, VL will be simply equal to this IL into RL. Okay. Now once you know the VL as well as IL, so then power P is equal to VL into IL. Okay. Right. So for all the resistances, you can find the current, you can find the voltage drop, and you can find the power. Okay. So now you have to observe the at what condition the maximum power will be delivered to the delivered. Okay. So now if you observe this list here, the power list, right? So in this list, what is the maximum power? Okay, that you have to observe, and for that, what is the resistance here? Okay, you have to represent. So the maximum power will be delivered to the load at some particular resistance. So, but if you apply the maximum power transfer theorem definition here, you can directly say, okay, according to maximum power transfer theorem, whenever the load resistance will become equal to the source resistance, so then maximum power will be delivered to the load. Okay, so directly you can say here. Okay, according to maximum power transfer theorem, so whenever RL is equal to RS, maximum power will be delivered. Okay, now the RS value is given here, so which is 45 ohms. So when RL is equal to 45 ohms, then maximum power will be delivered according to the superposition. Okay, and the maximum power value Pmax will be equal to how much? Vs square by 4 RS. Okay, so instead of TH, I am writing Vs. Okay, Vs square, Vs will be given 20 square by 4 into RS value again is 45. So if you find this, you will get the maximum amount of power transferred to the load. Okay. So from this circuit, you can even find out by considering here 45 ohms. First, you find the current I, right? So the current I is equal to 20 by 45 plus 20. So this is the load current. Okay, under maximum power transfer condition. Okay, and voltage drop will be load current into resistance 45. Okay, so like this you can also calculate. Okay, so you do this. Okay, right now. So another problem here, if you see, to find the value of resistance R in the circuit below, such that maximum power takes place, and also find the amount of maximum power. Same. Okay, here resistance, you remove this resistance, and you call the terminals as A and B, and you find the Thevenin and Thevenin between the terminals A and B, and you draw the equivalent resistance, sorry, equivalent circuit Thevenin value. Then replace the terminals here A and B with the R. Okay, now according to maximum power transfer theorem, when R is equal to RTH, then maximum power will be delivered. So and Pmax value will be equal to the Thevenin square by 4 RTH. So you also do this as your homework. So another problem also the same. Okay, here also RL. So you remove the RL, consider these terminals as A and B, and between A and B, you find the Thevenin and Thevenin, and replace the entire circuit like this. So Thevenin, Thevenin, and R. So you can simply calculate the maximum power transfer theorem. Maximum power transfer to the load. Okay. Right now, it is time up already. So thank you. Permission. Excuse me, everyone. So you rename your name with a roll number. So Pranav Reddy, Devi Sri, Sufyan, K. Kuzma, Abmanti. So you will not get the attendance. So you rename with your roll number. So we get absent mark. First you rename roll with your roll number. Sai Sandeep. Who is Sai Sandeep? Devi Sri, Ujma, Abati.